For a rocket to be able to take off, there needs to be a force generated by ejecting material in one direction. As per Newton's third law of motion, this principle is often expressed as action and reaction. When a rocket expels exhaust gases in one direction, it experiences an equal and opposite force propelling it in the opposite direction, making the rocket soar in the sky. In this video, we will illustrate how a rocket can lift itself by the concept of action-reaction forces. In this experiment, we would be using balloons, nylon string as our guide wire, straw, and tape. Step 1. String the guide wire or string across the room. Make a rocket system that will propel itself across a classroom on the wire or string. Use a balloon for the rocket power and the straw, paper clips, and tape to make a guidance system. In this trial, we tied the nylon to a chair to make a straight line. To start the experiment, place the balloon's end. Step 2. Getting there is only half the problem. Make a rocket system that will get across the room and then come back again. To make the balloon come back, we used 2 inflated balloons and stuck them side to side, locking the air inside using binder clips. The same preparations were made as in step 1. This time, the first balloon, the blue balloon, would be released first. It would be followed by releasing the white balloon so that the air inside would be used as a force to push the balloon back to the starting point. In step 1, the balloon indicates how the rocket works following Newton's third law of motion. After the balloon is released, the reaction of the balloon moves forward with the help of a guide wire as the air comes out from it. The same thing with step 2, and the only difference is that it is symmetrical, when the first balloon is going to be released first to reach the end point, and for the balloon to get back to its initial point, the other balloon is released. The balloon shows 2 forces, action and reaction. The action here is where the air comes out from the balloon, while the reaction is the consequence of the action force, causing it to move in the actual concept of the rocket. It is launched vertically with the help of high-speed gases, causing it to lift off above the Earth's surface. And most rockets are multi-stage, that uses 2 or more rocket stages, each of which contains engines stacked together and propellant. In this case, the blue balloon indicates the first stage called the booster engine of a rocket, where it lifts itself above the Earth's surface. When it reaches its maximum velocity, the engine runs out of fuel, detaches from the rest of the rocket, and falls away. This allows the second stage of the rocket, which is the white balloon, to propel independently, following up the first engine and keep going without having to drag along the extra weight of the empty fuel tanks. As it moves into space, rockets travel along a parabolic trajectory, primarily due to the influence of gravity, which bends the path of the projectile into a parabola. An inflated balloon moving when the air escapes can be explained by Newton's third law of motion, which states that for every action, there is an equal opposite reaction. In this experiment, the air coming out from the balloon is a high-pressure air that rushes out and creates a force, making the balloon propel in the opposite direction. The rocket action relies on the exhaust gases, or in the experiment, the air inside the balloon, to move. Newton's third law of motion doesn't depend on the presence of air or any other medium. Therefore, the absence of surrounding air doesn't affect the process of the action. For every action, there is an equal and opposite reaction. The inflated balloon demonstrated how action-reaction forces occur in an actual rocket. An inflated balloon can cause 2 forces when released, action and reaction. The force of the air escaping is the action, and the movement of the balloon forward is the reaction. Therefore, the rocket is evident in the physical principle of Newton's third law of motion. All experiments showcase Newton's third law in action, where escaping air from an inflated balloon propels in the opposite direction. In the context of rockets, we learned that their action doesn't require surrounding air. They work by expelling matter, consistent with Newton's law even in a vacuum.